So welcome. Today I'm going to show you Apache Zeppelin. So let me introduce myself first. My name is DuyHai DOAN. I am working as a technical advocate for Apache Cassandra. So if you have any questions about Cassandra, you can just ping me on my email or on my Twitter handle. I am working for DataStax. Apache Cassandra belongs to the Apache Foundation. DataStax, we are a commercial company behind Apache Cassandra. And the idea is to provide an enterprise version of Cassandra. So, I am an evangelist for Cassandra. Why am I here to talk about Apache Zeppelin, right? The reason is very simple, because I love this project. First time I saw Zeppelin, like 6-8 months ago, I thought, wow, really nice. And then I started using it, contributing to it. And that's why I'm showing it today to you. What is Apache Zeppelin? So on the website, you can read this. They claim to be a web-based notebook that allows you to play with your data, to share the data with your friends, your colleagues, using SQL, Scala, and more. So let's start with a demo. Oh, problem. Okay. So this is the main interface for Zeppelin. Okay, Zeppelin is a notebook. So on the main page, you have many notes. So for the demo, I have downloaded some dataset, albums and artists. Okay, so I put it in my temp directory. So I just do some shell script to show you the content. So this is for album, and this is for artist. Okay, you have some artists, their country. So we have like 110,000 albums and 11,000 artists. So for this dataset, I'm going to use Spark to perform some data processing. So first I declare a function, compute decade. So it's an user-defined function. The idea is I give Spark a year, it returns me a decade. For example, if I give 1965, Spark will give me back 1960, 1970. Okay. Now, the data has been inserted into Cassandra. I will declare into Spark my Cassandra table. So the key space is music, the table is artist. I also declare the album table. And now, since I have declared them into Spark, I can use Spark SQL to perform analytics. So here you have a join. Okay, I want to join artists with albums, some filterings, group by decade and country, with a having clause. Okay, so let's just execute this query. I want also to filter out all the country which has less than 200 album counts. Okay, so this query will answer the question, give me for each decade and country the number of albums. So here we are, for each decade, we have the number of albums, okay? Now what I can do is, for each decade and country, okay, let's zoom in, so it's a little bit ugly. Let's just modify the threshold. So we have less data to show. Okay. So you see for each decade and for each country, you have the number of albums. So here I'm using Spark to perform analytics on my data which are in Cassandra. I can also use directly Cassandra query language to do a full text search on my data. For example, give me all albums which contain the love in the title in USA between the years 1970s and 2010. So here we are. Okay. So as you can see, in the same node, you can have many processing with many languages. Spark, Cassandra, shell script. This is the architecture of Zeppelin. So on the front, you have AngularJS and Twitter Bootstrap for the look and feel. And NVD3, which is a library to allow you to have graph. Okay. On the back end, you have a Zeppelin server, which basically is just a Java web server. It exposes two endpoints, a REST service to create a new node, a new paragraph, and a WebSocket to be able to push real-time updates back from the backend to the front end. But in fact, Zeppelin is just a proxy server. Zeppelin do not perform the logic for you. The logic is inside each interpreter. That's what we call interpreter. Okay? So here we have a Spark interpreter to execute Spark code. You have Cassandra interpreter to execute Cassandra code. And you can have many different interpreters. Each interpreter is running in a separate JVM. The reason is because we don't want to have class pass issues. Okay? And each interpreter JVM is communicating with the Zeppelin main server using a Swift protocol. It is a binary RPC, request response protocol. So, Zeppelin will give you for free a front end and a display system. So, as you see, I didn't code any JavaScript source code, and I have beautiful graph. You have a pluggable interpreter system, and you have also a task scheduler, like a cron system to schedule your task. We will see later. First, let's zoom in the Zeppelin layout. So, from demo to Faker. So inside a Zeppelin node, you have many paragraphs. This is one paragraph, this is another paragraph, another one. Each paragraph has an ID. You can click on this button to run the paragraph. You can configure each paragraph. For example, I can change the title. You can reorder them by moving them up and down. You can also change the width of each paragraph. So in fact, since we are using the Twitter Bootstrap grid system with 12 columns, so here I change to 6, okay? And if I update this paragraph width to 6 also, they will be reordered automatically, okay? In each paragraph, you have two sections. The source code, here it is Markdown, okay? Markdown source code. And the result of the execution of your source code. On the node level, when you click on this red button, what happens is Zeppelin will execute each paragraph in the order sequentially. Okay. What is interesting is you can clone the node. For example, you say, okay, I have my source code here. I want to try something different, but I don't want to lose my original data, so I can clone the node to create a new one and to play with. Or you can export. You want to save your source code, so you can export the node as a JSON. Okay? So I export it to save it somewhere. And to import it, you go to the main menu, you click on import, and here we are. Okay? And last but not least, we have a scheduling feature. For example, here I have a shell script, okay? I'm displaying the current date, so if you click on play, it is 2 p.m., 8 minutes, 24 seconds. Now imagine that I want to schedule the whole node to execute all my paragraph every 5 seconds. So let's see, 40. 45, you see. It means that you can now create an analytics pipeline, so you have many steps to process your data, and then you schedule the whole node to be executed every 5 seconds, 10 minutes, every day, every hour, every week. So it gives you, for free, a scheduling system. So just deactivate it. And of course, as you have already seen, in each paragraph, you can choose the type of language you want to use. For example, if you put %MD, it means that you are using the Markdown language. If you put %SH, it is the shell script interpreter. Angular is for rendering pure HTML code, Spark for Spark code, Cassandra for Cassandra code, and so on. Now let's move to the display system. You have already seen a little bit of it. Let me explain it into the detail. So by default, you can display raw text data very easily. So here I have a Spark, okay, a Scala interpreter. I just print this raw display. Okay, fine. You can also display your data as a table, like in Excel, with rows and columns. So the formatting is %table, and then the first line is the header of your table, and then you put as many lines as you wish. To separate each column, you need to put the \t, which is a tab. So if I click and play, here we are. There I have a table formatting. Very simple. You can also, if you wish, display raw HTML format. Okay, so you just use %HTML, and then you put plain HTML code. Okay, you can also mix table formatting with HTML. So for example, in my table, I want to put some special color in this cell. So just change it to red, for example. Click. So here we are. The 27 is in red. Okay. I don't know if it's very visible on the screen. So just change it to blue. Okay, blue. Graph display. This one is the most interesting feature of Zeppelin. If you are able to format your data as a table, Zeppelin will allow you to switch to a graph display automatically. So for example, here I created a fake data set of 5 persons, okay, 5 users, John Doe with their age, and then 2 Richard Smith, and so on. So I'm manually formatting my table display here with the 2 columns, name and age, in Scala. So here we are. So this is my table formatting. And since I have a table formatting, I can switch automatically to a bar chart or a pie chart or whatever you want. Okay? And what is much more interesting is, just remove it. You can perform client-side group by. So if I want to group user by age, so this is the grouping key, age, and then I put name here, count, give me for each distinct age the number of users. So I have 3 users which are 27 years old, 2 users which are 32, and 1 user which are 45 years old. Okay? Dynamic form. As you have seen here, I have some input text here. So what is it? It is a dynamic form. There is a special syntax. If you don't want to hard-code it, the value or the parameter for your code, you can use this syntax, so $ and then brackets. The first text is the label of your input text, and then this value is the default value. So if I execute, it is a markdown, okay? This is a title, this is blah, 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 okay? So it is updated in real time. It will rerun your paragraph every time you update the text. You can have also drop down. In this case, you need to use a special syntax from Spark, which is z.select. So it's a drop down. And here you need to provide a sequence of key value. Okay? The key is the original value, and the value is the label which is displayed on the web page. So if I click on this, so I have selected 2. Now if I switch to 3, the code will be updated, and then selected value is 3. Okay? View mode. Here I have a very simple display, which is for developer because I have source code and I have the rendering. But if I want to show to my boss my graph, my graph, for example, I can switch to report. Okay. In this case, my boss only see the result. There is no source code anymore. But the problem is, if I copy paste this link and give it to my boss, he can play with my node and he can switch back to the developer mode and he can change my source code. And I don't want my manager to change my source code. I want him only to see the result. So how can I do it? Very simple. There is a very nice feature which is export as iframe. So here, link this paragraph. So here you have a link. You copy paste this link, and then you create yourself HTML5 from scratch. Okay, and then you put this link in an iframe. You start. Imagine that you put this HTML page on another web server, and then localhost iframe export. So here we are. So this is what you want to show to your boss, and not the other page. In this case, your boss cannot change the source code. There is nothing, he can click everywhere, he cannot update the source code. And what is nice is that still with dynamic form, he can still update the display. Okay. And what is also nice is you have a two-way binding. So if, as a developer, I update my data here, my boss will see the result in both ways. Okay. So if I change the display to bar chart, for pie chart, sorry, my boss will see this. So it means that you can update in real time the source code, and your boss will see the graph updated in real time. Nice. So let's go back to the slides. There is an extra feature that it is exclusive to Zeppelin and you don't find in other notebooks, which is streaming. We are talking about big data here. So when you are deploying on production, your big data pipeline, sometimes you have a stream of data, continuous stream of data that is coming in forever. So the idea for streaming is, imagine you execute a query on your interpreter on the backend, and the data are coming by page. Okay? Zeppelin will allow you to push new data coming in from the interpreter back to the front end using WebSocket. Some demo. Okay.
I have a question.
Yes.
Is it okay?
Sorry.
I have a question. Is it okay now or at the end?
It's okay now.
So you're just playing with the data and regrouping and stuff. When having a large data set with a response, how is that kept in memory?
It's kept on your browser. So
what data set has 2 gigabytes?
So I think your browser will die before the 2 GB arrive at the backend. So Zeppelin is used for data analytics visual. Okay, visual analytics. It means that you are not going to fetch with Zeppelin the whole database. It's just here for interactive analytics. So it means that you need to filter maximum your data set so that you don't have like 2 GB of data. Because anyway, who is going to look into 2 GB of data? Nobody, right? If you have a table with 10,000 lines, nobody is going to play with it anyway. So it's more database tool here. streaming. The idea now is I execute a code on my backend, and every time there is a new data will be pushed back to the web. Okay? So for example, I have a very simple example. From 1 to 5 for each, I will sleep 1 second, and then I will print hello. So let's see. Hello 1, hello 2. So this is streaming, right? So imagine you have a query that returns you a 100 result. But then you want to see by 10 by 10, so you can do this kind of stuff. So you see first 10 results, and then it executes, and then next 10 results, and so on. The same thing can be done with a shell script. Very, very silly. So for I in 1 to 5, do sleep 1 second, echo I. But right now, the streaming feature is very new, so it is very limited. It is limited only to text output format. If I want to have a table formatting, I cannot use yet streaming, because it means that I need to format my new data with a table format. So it's not very difficult to implement, and I may do a pull request to them. But at least the core feature, the core plumbing is already there for streaming. Now let's see interpreter system. In fact, the real strength of Zeppelin is the interpreter system. So what is an interpreter? In fact, every time you are doing some source code on the front end, Zeppelin will just take the bunch of input text and forward it directly to the interpreter. Zeppelin will not modify your source code. Zeppelin doesn't even know what is inside your source code, in fact. So all the job is done by the interpreter. By default, you have 4 core interpreters, so the Spark one, Spark SQL that defined by Spark. Okay. You have the shell interpreter, we have already seen the Markdown interpreter, the Angular interpreter. And because it is an open source project, many people have developed extra interpreters for extra framework. So here, list. So there are more than that, but I don't have enough room in my slides, so I just limit the list here. So you have interpreter for Flink, Apache Flink, Apache Cassandra. I wrote this interpreter. Someone created the interpreter for PostgreSQL, for Elasticsearch, for blah blah blah. How can I configure my interpreter? And how can I use it? So here on the node, if you click on this icon, the gear icon, you can see a list of all available interpreters. Okay, I have Spark, Angular, Shell, blah blah blah. So now imagine that I deactivate, I remove the Markdown interpreter from my notebook, save, and I try to execute Markdown. Error. Okay. Of course, because now I have deactivated Markdown. I put it back. Okay, very simple. So on each node, you can choose the list of interpreters you want to use or not. To configure the interpreter, you need to go to this menu. For example, here is the Spark interpreter. You have many properties for Spark. For example, the master, the IP address of the Spark master. So here it is local because I'm using on my laptop. But if you use it in production, you might put the real IP address here. For Markdown, there is no properties because it's quite simple. There is nothing to configure, and so on. Okay, you have properties for different interpreters. Okay. Now, how to write an interpreter? Let me show you. It's very simple. You decide to write an interpreter because you want to use Zeppelin for your technology. Okay? Right? First thing you need to do is to create a class that extends the base interpreter base class. Okay? Then register your class in a static block. Don't ask me why static block, ask Zeppelin people. Okay. Optionally, you can define default properties with the property builder. So what are those properties? If you remember, the properties are, every time I switch screen, it's like this. The properties are those value here, key value, key value. Okay. And then, once you create your class, you need to register your class into Zeppelin. So there are two ways to do that. First, you edit the menu. There is a configuration file, then you have a menu. You just put the fully qualified class name of the interpreter inside. It means that you are modifying Zeppelin source code. Or if you are nice, you don't want to touch Zeppelin source code, you can use runtime configuration. It means that you can update the configuration file. There is a property called Zeppelin.interpreters, and then you put the name of the interpreter here and restart Zeppelin. So, two ways to do the registration. So, let me show you how to create an interpreter. Let's take an example, very simple example, AsciiDoc. Okay, AsciiDoc is very similar to Markdown. It is a formatting, text formatting language. So the idea here is, I am writing some AsciiDoc from the front end. Zeppelin will just forward it to my interpreter. My interpreter will execute the formatting to generate an HTML content, and then I return back the HTML content, and that's all. So let's see some source code. Non-linear, very simple. Here we are. So this is my AsciiDoc interpreter. So as I said, is it visible in the back? Or should I zoom in? Okay. Extend interpreter, the ugly static block, remember? And then, of course, I need to pull a dependency on AsciiDoc.j, which is a library to format AsciiDoc. You have two methods, open and close, so it is for initialization of your resource. In this case, I'm just creating an instance of my AsciiDoc. And the most important method here is interpret. Okay? I have string st, which is the input text, and then interpreter context, which contains some data related to your node and paragraph. The only thing I do here is I use my AsciiDoc, convert my input text, and then I get an HTML output, and then I return the result. It is that simple. 2 lines of code, and I have an AsciiDoc interpreter working. You don't need to modify the order method. Let them by default, it's fine. Okay. So let's see simple AsciiDoc interpreter. So here I have some AsciiDoc syntax, okay? This is AsciiDoc syntax. So now AsciiDoc, I choose my interpreter, and then I copy paste, I click apply. So it is taking some time because the first time you execute one interpreter, it needs to start a new JVM. But then the second time, if I click again, it is very fast. It's done, okay? So this is the result. Okay, okay. Now let's see something more complicated. You can create something very simple but very complicated. For example, the Cassandra interpreter. The idea here is I have insert, update, delete, select. I have a bunch of statements, Cassandra statements. All of them are sent in one block of text to the interpreter. So the job of the interpreter here is to split split every statement individually and to execute each of them against a Cassandra cluster. The Cassandra cluster will reply by a result. So if you have insert, well, you don't have any result back. If you have a select, you will have a table of data back. And then the job of the interpreter is again to format this table properly and to return the result to the web page. What is interesting here is because I am controlling the input block of text, I can create myself my own magic command. For example, in Cassandra you have only standard query like insert, select, delete, update. Okay? Create table. Describe table doesn't exist in Cassandra. It does not exist. If you type describe table, error. But because I am creating my own interpreter, I can intercept every statement. I can create my own command if I want. Okay? I can create my own logic. So I create a logic for describe table, a logic for help. This command does not exist in Cassandra. Okay? So what happens is if someone is typing describe table, I intercept this command. I am calling an API to get the description of the table from Cassandra, and then I format the result back. So it means that you can create your own extra commands. Let's see an example with a demo. So for example, as I said, so if I do a select, a normal select, start from music.artist, delete this 10, okay? So give me 10 first 10 result, okay? So this is standard Cassandra. I don't do anything, I just format the result. Now if I do describe table music.artist, what happens here is I can design my own rendering. Okay, so this is my own rendering because I intercept the describe table, and then I can format the answer like a table display or whatever. Okay, and you have like describe key space, for example, music. If I do this, I can have like okay a description of I have a list of table in my key space, a material view, some function. I can have a menu, an interactive menu here. So it is all Twitter, Bootstrap, and AngularJS, okay? Nothing wrong. So how is it possible? Well, it's very simple because since I can control the flow of commands, so what I did is I create from the backend some HTML templates, right? And then I just inject at runtime the values. For example, someone is doing a describe table. I call the API from Cassandra to get the description of my table and inject into this template, and then render it, and that's it. So this is an example of something more complex than the simple AsciiDoc. Okay, to finish, so complex interpreter. You have, for each interpreter, you have their documentation online in their website. So I show one for Cassandra, you have one for Elasticsearch, for PostgreSQL, for Spark, and the future of Zeppelin. To be able to be deployed in production, you need security. Okay? So they have already done an integration with Apache Zero for authentication. There is a pull request for authorization on each node, so who has the right to see or to execute this node. There's some work being done on the interface, so you can export the data, the table data, export as CSV, as PDF, as Excel format, to paginate the table too. And last but not least, they are thinking about a pluggable system. So because right now we have a very limited choice for graph. You have like 5 or 4 different types of graph available. The idea is to provide more graph, but on a plugin basis. So you have a list of graphs you want to use for each of your nodes, and you can pick and choose. And more important, we need also more interpreters. For example, now we have already a big list. Someone is working on interpreter for HBase. There is an interpreter for the R language. So if tomorrow you don't find any interpreter for your backend, you can write yourself one and just submit to the community. Okay. Question?
I have a question.
Yes.
You said there at one point that if I choose to write my own interpreter, you will be able to then dynamically start my JVM for my interpreter. So I don't need to restart the Zeppelin.
Now, when you write your new interpreter, you need to declare it in the source code of Zeppelin, at least the Maven module, and then you need to compile. Of course, you need to compile the project, and then at runtime, it will start your interpreter. Well, there is no magic.
Okay, so you need to...
Yeah, you still need to compile it, of course.
And about the custom comments that you're able to add, that one also needs
the custom comments. So let me show you.
The describe.
Okay, let me show you something.
So you modify the template.
Yeah. Now, in fact, for the challenge when you have a list of commands like this, insert, update, delete, the challenge is to be able to split them. Because if I push to Cassandra insert together, it will fail. Okay? Because Cassandra can only execute command by command. So the challenge is to be able to split. So what I use for this is what I call scalar combinator parser. So maybe you don't know what is scalar or combinator parser. It is just an engine. So you define the grammar. Okay. So this is a grammar. A mutation statement is a list of insert or update or delete or bind with that statement, and then you define pattern matching. You define some pattern with regular expression, and then the combinator parser will split, will pass automatically for you. So this is the technology I use. You can use an AngularJS parser if you wish. You can do anything. The choice is yours. And then once you have succeed to split all the commands, you can patch your own extra command and do a custom processing. This is, for example, for the describe, I have some custom processing because I can distinguish it from the insert or the select or whatever. Yes?
Is it possible to plug in something like autocomplete based on what you have described or Angular?
The problem is the backend is very, very flexible because you can choose your technology. The frontend is not. The frontend, everyone is using the same frontend. And that is the problem. There are already questions from the community. How can I have like autocomplete? Because, for example, if I type select, then I want to have autocomplete. The problem is if we implement an autocompletion, code autocompletion, we need to support for each interpreter, which makes it much more complex. Because everyone is going to modify the same core frontend. And it can be very dirty. Other question? Yes.
I still want to repeat my question. So my question was that you write something like select, you have a person with age and nationality, and you select 1 million persons from your database and you want to group them by nationality. So you have a pie chart with 10 slices. Okay, and you want to send that to your manager, and you showed us that you can dynamically change the group by.
Yes.
When he groups by age rather than nationality, he has to have the whole data set, right?
Yes. In fact, the group by I have shown you is done client side.
Yeah, so
yes.
How do you transfer all that data?
It's in your browser. Yeah, there is no logic. So if you want to show a huge data set, the recommendation is don't do like select star. You don't want all columns. You want maybe age or name, for example. So select age and name. So it will fetch less data. But in the end, there is no magic. If you need to go by 1 million users, yeah, somehow you need to fetch 1 million data on the web browser. There is no magic.
Okay. I was asking because that can be a much more.
Yeah. You are right, I think, but yes, they have. And I asked already this question. I wanted them to implement like a paging feature because oh, I want to display 10 million. But anyway, your browser will die before you load 1 million. So they is thinking about paging. It means that you look at your data page by page. So every time you change the page, you will remove the data from the last page because you cannot keep everything in the browser. Anyway. Question here.
What are the plans in terms of themes or internationalization, changing the look and feel a little?
Oh, yeah, the look and feel. Well, as you can see, this is my own look and feel because I can create my own formatting, my own display, my own outputs with plain HTML. For the general look and feel, I think they are using Twitter Bootstrap. So if you hack into the CSS of Twitter Bootstrap and you change your object, the color scheme you can change.
Okay.
And then, yeah, it's very classical.
And plans for internationalization?
I don't think so. I didn't see any Jira ticket about internationalization.
You have for supporting Spark streaming. If you want to text, it could be processed, but I don't know if you have plans for include like you did for streaming text.
For streaming text, well, there is some. I have shown the demo,
Yes.
but Spark streaming right now is not working very well with Zeppelin because, in fact, when you run Spark streaming, it will block.
Yes.
Because, in fact, Zeppelin is like a Spark record, and you take one core. So if you don't configure the number of core and you just give it one core, well, you can't do anything else when you launch your Spark streaming job. So right now, I never succeeded to use Spark streaming with Zeppelin, to be honest. Other question? No? Fine, thank you.